Alright, ladies and gents, here we are with yet another fun lesson in geometry. We are in Chapter 12, Section 2, Volumes of Pyramids.
Talked about the volume of prisms previously, and we found that the area was the base times the height, and that was the area of the base. The volume, how much fits in there, is the area of the base times the height. Now we have pyramids. Now, this pyramid has the same base area. So these have the same area of the base, same size base, just this is a pyramid. Okay, we want to figure out how does this volume compare to this one. Notice they also have the same height. Okay, so I can place this in here and it fits in there perfectly. It has the same height and it has the same base area. Okay, now to figure out the volume, I can fill this one up. And then I can dump that in here. And see how much of the volume is that. Now if you were to look at that, you can see, that, okay, it's below the halfway mark. Okay, that's about a third. And actually it should be, if we've done it exactly, it should be exactly 1/3. So the volume of a pyramid is 1/3 that of the prism with the same base area and the same height.
So copy this down into your notes. The volume of a pyramid is 1/3 base times height, where B, capital B, again refers to the base of the shape, base of the pyramid. And that goes for a right pyramid just as it does for an oblique pyramid. Let's have a look at a few examples. Okay, finding the volume of a pyramid. So, base times height, in this case, the base is a triangle. So remember, the volume is 1/3 base times height. Now, we could also write that as base times height divided by 3. Those are equivalent. The base here is a triangle, so that's 1/2 base times height. Now, confusing here, base times height of a triangle and base times height of the pyramid base. This is base area. This is the side 4 times 6. Half of 4 is 2. Times 6 is 12. So that is the base of the pyramid. So we can do 12 times 9. We can simplify either one of these. This gives us 3. 12 times 3 is 36. And the unit here is meters cubed. Okay, here we have a pyramid. The original height was about 144 meters and a volume of 2,218,800 cubic meters. Find the side length of, this is important information, the square base. Okay, a square base, that means to find the area of the base, I can take a side squared. All right, so again, volume is 1/3 base times height. Okay, and then we can replace base with side squared, so then we have 1/3 side squared times the 144, and on the other side we have the 2,218,800. Didn't leave myself a lot of room there. All right, now I can divide both sides by 144 and multiply by 3. Doesn't matter which one you do first. If we multiply by 3 first, let's do that. Times 3 here, times 3 there. This will cancel out the third. And then we get 6,656,400 is equal to 144. That's a 4 there. S squared, divide each side, different color, there we go, divide each side by 144, and we get the side squared is 46,225. Now, we have to square root that in order to get what the side length is, and that is 215 for S. So the side length is approximately 215, and this was in meters, 215 meters. All right. Find the height. We know the volume, and we're given the dimensions of the base. All right, this time we want to find the height. So volume, again, is 1/3 base times height, or base times height, divided by 3. So in order to find that, we want to, this time I'm going to solve the literal equation. How about that? We'll solve that for height. So we'll do times 3 on each side, times 3, times 3. Then that cancels this out. Now we have 3v is equal to base times height. We're solving for height, so we have to divide by b on each side. Solving literal equations is fun. Now rewrite this. Height is equal to 3 times the volume divided by the base. So that's 3 times 14 divided by, and the base is 1/2, 4 times 3, and that makes that 2 times 3, which is 6. 6, we can simplify this. 3 and 6, that gives us 2 here. 14 divided by 2 is 7, and that is in feet. All right. Let's see, finding measures of similar solids. Now remember that the volume, the scale factor of the volume is cubed to the scale factor of the sides. And the scale factor K, remember, was new over original. All right, since this is pyramid B, we'll have new be H. So that's H over 8. All right, and that behaves cubed in comparison to the volume. So this cubed is like the volume of the new, 40.5 over the volume of the original, 96. Okay, that gives me H over 512 is equal to 40.5, over 96. Multiply each side by 512 to cancel that out, times 512, and then type that in, and we get H, sorry, this should be H cubed. H cubed is 512, and now to find what the height is, we need to do the cube root. Cube root of 512, and that is, oh goodness, sorry, I'm getting carried away here. Back it up right there. And this times 512 is 216. And the cube root of 216 is 6. There we go. Okay, we have a composite solid. That gives us the pyramid and this prism. Now, it's a rectangular prism, but you'll notice it's actually a cube. So the volume of each of these, the volume of the total is the volume of them combined, right? I have to add them together. So I can take volume of the pyramid. The volume of the entire shape is 1/3 base of the pyramid times the height of the pyramid plus base of the cube times the height of the cube. All right, 1/3. Now this base right here is 6 by 6, that's 36. So 1/3 of 36 times the height is 6, plus this one's also 36 by 6. 1/3 of 36 is 12 times 6, plus 36 times 6 is 216. And then 12 times 6 is 72, plus 216. The volume of the entire shape is 288, and that is in meters cubed. It's a cube. Boom. All right, ladies and gentlemen, that was lots of fun. Good times for everyone. Wink. There we go. Check in again next time for another fun lesson.